Hello everyone, let's see this question. In a convoy on a long straight level road, 50 identical cars are at rest and the separation between them is 10 meter. Constant acceleration 2 meter per second square can be provided while starting, and maximum deceleration on applying brakes can be 4 meter per second square. When the order is given, then the first car starts immediately and the subsequent cars start when its distance from a car that is immediately ahead becomes 35 meter. So like this car has started and this will move for 25 meter, then the next car will start. This is what is given. Okay. Maximum speed limit on this road is 72 km per hour. When an order is given to stop the convoy, the driver of the first car applies brakes immediately and the driver of each subsequent car applies brakes with a certain time delay. The time delay is not given after noticing the brake light of the front car turn red. When all the cars are moving at the maximum speed, what is the separation between two adjacent cars? So we just now understood that this car will move for 25 meter and that will take, so we'll use s is equal to half at square. So for moving 25 meter with an acceleration of 2 meter per second square, it will take 5 seconds, right? So for 5 seconds this has been moving and then this begins to move. Okay, so we have to find, once both have attained their maximum speeds, then what is the separation between them. So let's understand by this graph. So in this graph, let me plot first the velocity variation of the first car. So for our car number 1, let's say velocity changes with time like this, then it attains a maximum value which is 72 km per hour. 72 km per hour means 20 meter per second. Now the next car, it starts after a time delay. How much is the time delay? 5 seconds. So 5 seconds later the next car starts and that also moves in the same kind of graph and then attains its maximum value. So the increase in separation between them would be this area, right? And how much would be this area? This is just a parallelogram. So for a parallelogram, the area is how much? It is base into height. And how much is the height over here? It is 20 meter per second. And then when we calculate the area, we'll get 20 meter per second into 5 seconds, which gives us 100 meter. So the separation would have increased by 100 meter, and hence the new separation is what? 110 meter. Okay. Next question. During the time when the motion is building up in the convoy, some of the cars are moving and the others are at rest. What is the average rate of change in length of the segment consisting of stationary cars? So let's understand it like this, that when this car moved, the length decreased suddenly by 10 meter. Then when the next car moved, then again it decreased by 10 meter. So with the beginning of the movement of some car, the length of the stationary convoy reduces stepwise by 10 meter, and this happens after every 5 seconds, right? Every 5 seconds after the start of one car, the next car starts. So that means the length of the convoy reduces by 10 meter at each 5-second interval. So on an average, the reduction in the length will be how much? It will be 10 upon 5, which is 2 meter per second. So it is decreasing at the rate of 2 meter per second. Okay. Let's see the next question regarding the same paragraph. When all the cars are moving at maximum speed, an order is given to stop the convoy. If all the cars decelerate at equal constant rates and separation between every two adjacent cars again becomes 10 meter after the whole convoy stops, what can be the deceleration of the cars during the braking? So it's given here that finally the separation again becomes 10 meter, which means that it is reducing from the current 110 to finally 10, and that means the relative distance that must be covered would be 100 meter, right? So again, let's draw the graph. Let's say for the first car, the graph is like this. I'm drawing the graph at the moment. My graph begins from the moment the first car begins to decelerate. So when the first car begins to decelerate, you will have this kind of graph, and finally it stops. Now the next car will continue moving for some time, okay, and then it will notice the red light which is illuminated due to the brake, and then it begins to decelerate in the same way as the first car. And once again, we can use the previous idea only, that area of this parallelogram should be equal to base into height. Now in this case, area is already given to us, because it's given that initially it was 110 and now the separation is 10. So that means the area now must be 100. So this area we know is 100, and we are supposed to find what could be the deceleration. So we know that the maximum deceleration is what? Maximum deceleration is 4 meter per second square. It cannot be more than that. But look at this graph. What do we want here? We want delta S to be 100. We know that this is 20. So we know that this time gap has to be how much? This time gap has to be 5 seconds. Then only the area 5 into 20 will be equal to 100. Only this is the requirement. There is no requirement for the slope. So the first one can decelerate like this, and then the second one will also decelerate in the same manner. But still the time gap should be what? Same 5 second. And if it is 5 second only, then again this area will be what? 100 meter. So it doesn't matter with what deceleration the cars finally come to rest. What matters is that the time gap between the deceleration should be 5 seconds. So that is not mentioned in the question, but given the data, we can find that out. That has not been asked also. But what we have to understand is, you can have any value of deceleration lesser than 4 due to the fact that maximum acceleration is 4 only. And still, what will happen? If time gap is 5 seconds, then final separation will be 10 meter only. Okay. So the answer should be what? If it is a multiple answer question, we should take all three, A, B, C. But if it is a single answer one, then C is the best option. Okay. So that's it for now.